For those of you who don't know me, I am Oliver Grievson. I'm the Executive Director of Water Industry Information and Control, as well as being the Technical Lead at ZTech Control Systems, on top of a number of other things. I set up WIPAC in 2011, basically for knowledge transfer around the whole instrumentation, control and automation systems, as well as what's now being called digital transformation in the water industry. Over the next 12 months, and basically every year, we're going to be putting on a roughly monthly webinar with areas of people's interest within the industry. So today we've got radar. Next month we've got going to have flow to full treatment, which is an oncoming issue in the next asset management period. And we will see from there, but certainly we will have presentations by our governing members, who are of course ABB, Siemens, Xylem and ZTech Control Systems. Today is the first of the WIPAC webinars, so I want to thank you all for joining us at this first webinar. And we're very lucky to have Doug Anderson of Vega Control Systems talking about the dawn of new level sensors for the water industry. So that's Doug in the screen below. I will stop my video and we will switch over to the presentation screen and begin. So Doug, take it away.
Okay, welcome everybody. Again, I'll freeze my camera once I get going because nobody wants to see me staring at a screen for the next half an hour. We'll be going through the slides. I've got my colleague here, Tom, who's going to be, here he is.
Hi everyone.
He's going to be answering some of the questions on the chat as we go so that I'm not getting too distracted. And of course, if there's any other questions that we can't or want to answer afterwards, we will do. Get back in contact with people if there's any specific sort of technical information or sensors they actually want to see. So I'm going to pause myself now and begin the presentation, and I'll switch the camera back on at the end. Okay, so radar is the better ultrasonic, with a question mark at the end. That's a big claim from us, and the following presentation seeks to show you how we believe as a company that this technology is going to make a big change in the way the water industry gathers and controls with level data across all areas of the business and across into the environmental sectors and beyond. Just a quick overview of what we're going to cover today. We're going to cover the development of radar, but because there's a lot of people out there who still don't really know where radar comes from, it's just suddenly appeared on the scene. Some fundamentals about how it works, again, because a question we still get regularly asked is, what's the difference? Quick overview of benefits of using radar technology, and kind of just so that you understand why we've put so much time and effort into it over the last 30 years. And again, another new radar. I mean, we've been bringing out some radars to the water sector on and off for the last 7 years. And what's so great about this new one, and we'll cover that, along with an specification. And then at the end, we'll talk about where you can find all the price and specifications and details. So I hope that will cover in enough detail what you're uncovering. So what's the difference? Well, if we look at the incumbent technology, ultrasonic, it's a good proven technology. It's also still manufactured by Vega for now, and we've been doing that for over 40 years. That's because many years ago, we regularly discovered its limitations and decided to look for an alternative. In many industries, we saw issues mainly with accuracy and performance issues, like wandering measurement readings on vapors, sort of solvents and fuels in summer or in winter, depending if there's sun on the tank tops or not, creating more or less vapors inside the vessel, and temperature issues on the transducers themselves. And then we had filling into dead bands, causing level echoes to be lost, and we'll cover dead bands a little bit later. And then getting outputs falsely jumping down or resulting in overfills occurring. That was happening with our sensors. And then we saw issues of build-up and condensation on sensors in different applications, whether that was loss of echo from dusty conditions, very heavy turbulence, false echoes, temperature limitations and temperature measurement errors. And we saw crosstalk issues when we wanted to make multi-sensor measurements on solids applications. So there were workarounds for a lot of these in different applications, but they weren't really very satisfactory, and we still delivered questionable performance in some of these areas. And many of our customers had processes that could not be measured reliably due to just difficult, harsh environments, and we wanted to look for a technology that could help solve that. So this is a picture of our history from 1991, which is the year I joined Vega up until, well, the present day. So in response to some of these issues, about 30 years ago, our R&D looked at different technologies, and they explored particularly laser and radar and what could be developed and explored. Laser looked like a good technology, again, very focused and highly accurate, but it had the limitation of always needing a clear optical transmission path. And it needed extra workarounds for this, like lens heating, purging, wipers, cleaning, and it can't see through mist or vapors in the airspace either. And that's not good also with clear liquids. So we wanted a technique which was fundamentally more reliable, robust, and universal in its solution. So radar technology was already being used for level measurement at that time. So when we looked at it, we could see that they were being used on these massive oil storage tanks with a mill pond surface, a big transmitter, and a ticket price and complexity to match. But that was okay because it was accurate to the millimeter on fiscal tax regulated applications. So it met the criteria. But we could see that that basic technique was viable. Components become more available, so our work on a process version of these radar level transmitters began. But where was the market for these? Obviously, you can make a transmitter, and if it's going to be expensive, how does that work out for us? But there were plenty of willing customers in high-end chemical and pharmaceutical applications, as well as other industries with real difficult application challenges for level. But they had the budgets and the time to help us develop this new technology. The early radars were thousands of pounds and measured and controlled products and processes that were previously impossible, like high pressure chemical reactors, liquid gases, molten metal. It was seen as a complex luxury level device at first, but it was easy to see it had a lot of promise. It also got the reputation as a problem solver, but it's expensive. So in 1997, you'll see we launched the Vega Pulse 50 at 26 gigahertz. Basically, component prices have come down. We were able to make compact, more affordable loop-powered radar level sensors. And we had competitors in the market who were already joining us making radars saying, two-wire loop-powered, it's not powerful enough. But actually, they took the market by storm. They worked very well. And very shortly afterwards, we became number one in the process radar sector. And we've remained there for the last 25 years. We wrote a book on the subject, and now there's around 750,000 Vega radars in use worldwide. So in 2012, we introduced a dedicated water radar based on the 2009 Plix Plus system, which you can see again is 26 gigahertz. And we've got about 50,000 of those in use. But the only issue was we still needed to hit the right target cost. We needed to get the size compact and a startup time to be used in more applications in the water sectors. So this slide really shows you how started with something almost the size of a biscuit tin, and now we're something about the size, well, about 2/3 the size of a penny piece or a 1 cent euro coin. I think they're about the same. And that last chip is our own development. We developed our own radar chip. It's not a proprietary one. It's designed for level measurement. And we'll come on to some of those sort of benefits shortly. So what about 30 years of development? Ultrasonic sensors have nearly 50. So, you know, what's the big deal? But if we look back over the last 30 years, mobile phones are a really good comparison. They started with mobile phones. They make text, they make calls. And anything that resembled a smartphone was a luxury. And again, they were quite expensive, not user-friendly, quite complex to operate. But like all technology, these phones evolve continuously, and now the phones with touch screens and their apps dominate the market. They're sleek and filled with features and easy to use. And in a similar way, radar technology has evolved. It's enabled smaller, smarter, and more capable level devices. And just like the evolution of the smartphone, the cost of entry-level versions of those have reduced. Yet it's still got great performance. They're funding in part by the legacy development of higher specification products like Apple and Samsung. So you can go into a store now and buy for £20 a very ably equipped touchscreen smartphone that will perform many of the sort of basic tasks and download apps and run them. So for today, our threshold has been crossed with the design, development, and manufacture our own radar level chip. It's reached a point now it's cost effective for us to manufacture and end users to choose a radar sensor instead of an ultrasonic sensor for level applications and particularly water industry applications. And by the way, I had all four to the left and pretty much all four to the right in terms of mobile phones. I'll leave you to have a look on that little legacy photo there. So just to finish this part, give you a direct physical comparison. We're going to, talking a little bit about the difference between radar and ultrasonic. It's the difference between sound waves and microwaves or radio waves. They travel at the speed of light. Obviously, sound waves, the speed of sound. Ultrasonic sound wave runs at about 343 meters a second in dry air at 20 degrees C. And a radar radio wave is traveling at the speed of light, which is nearly 300,000 kilometers a second. And no temperature or humidity values needed there. And that's a little bit of a clue there. With sound waves, temperature and humidity reference is made because they're affected by the air and gas density and temperature they transit between the sensor and their target. And that was really what we wanted to overcome 30 years ago, and radar technology is really good at that. It changes the transmission time through the air for sound waves. So if it's not perfectly and evenly measured through the range, the temperature or humidity or vapors that might be present, because it could stratify, or they might gather nearer the top of the vessel or sit just above the liquid at the bottom, you will get measurement errors. Radio waves, conversely, are virtually unaffected by temperature and air density, with very few exceptions, with some special gases that are rarely seen anyway in the water sector. So this gives us a big and instant advantage for non-contact measurement. We can guarantee really good accuracy, and why we can use a non-contact radar to measure molten steel at 1400 degrees C as accurately as we can some cold water. So if you think of our picture here, just to give you the comparison, in the time it takes for an ultrasound pulse to reach the top of the Empire State Building, at the speed of light, a radar wave will reach the moon. So at that speed, how can we measure distance with millimeter precision over a range of a few centimeters? Well, it's not easy, and if I told you everything we do, I'd probably have to kill you because I've infringed several sort of patent secrets that we have. But 30 years ago, to get the electronic components to do this and these minute, incredibly fast measurements, they weren't readily available. They were almost military grade, and they were certainly not cheap. And engineering them to operate extreme temperature and pressures for the industries that could afford them, that was the big challenge. So to get a reflection back from the product surface, we had to be careful of things like low conductivity or dielectric products like oils, resins, and plastics, for the same reason you use a plastic bowl in your microwave. However, nowadays, you'll see we're using 80 gigahertz frequency. We're using the latest generation components, and I know I've said it before, our own chip, which is optimized, and it means we can measure even from the outside of a plastic vessel through the top and measure the liquid level inside, and that liquid could be an oil as well. We can measure fine non-conductive plastic pellets or powders or wood chip in silos, and that gives us still a great reflection. So just to cover really the radar benefits, enough of all the sort of heavy radar technicalities. So why do we spend all that time and money on trying to measure transit time at the speed of light. Surely it's easier doing it with sound. So in no particular order, we'll look at some of the benefits of the latest measurement techniques using our 80 gigahertz water radar. All conditions accuracy. We believe good data means better analysis and better closer control, less waste product, energy and time. So it's really important in the area of big data. We think reliable needs to be in the middle of those two words, to make sure that you get the best measurement you can from the field. And just like the radars on those fiscal oil tank levels we looked at in the early days, water radars have the same inherently good accuracy, linearity and resolution, straight from the transmitter. Our water radars we're talking about today, 2 millimeter accuracy and millimeter repeatability and resolution. And other 80 gigahertz transducers can do, for example, 1 millimeter resolution, and we do have 5 millimeters on our entry-level device. But we believe that to be better in practice. Those numbers are regardless of the overall measurement range. Radio waves don't stretch out like a sound wave in measurement range. As the range gets longer and the frequency gets lower, you tend to find that the actual wavelengths get longer, and so you lose a bit of accuracy. And of course, over those longer ranges, it's even more difficult to measure temperature evenly over that range. And for example, ultrasonic manufacturers will claim 1 millimeter accuracy output from a back-end transmitter or controller box, yet they're using data from a transducer where they have a stated accuracy of, for example, 0.25% or 6 millimeters, whichever is greater. And we find that an interesting conundrum. We've got to surely make sure that your device is 1 millimeter accurate before you go into your transmitter system. Radar has no deadband or blocking or blanking distance, but just to cover that, what is it? I still get asked by people, even who use ultrasonics all the time, about what is a blanking distance, sorry, or a blocking zone. They think it's something that's been put there by the manufacturer, and in fact, it's just caused by the fact that an ultrasound sensor works as a transceiver. This means it's a speaker and a microphone in one. In speaker mode, it vibrates to make the sound pulse, and then it switches to microphone or receiver mode, and the speaker has to be still to become a receiver, so it can hear the returning sound or pulse or echo to make the distance versus time calculation. To stop this vibration takes a short period of time, and that translates into a distance it can't measure. As I said, it can be called a dead zone, blanking zone, blocking or blanking distance. It can't be avoided unless some mechanical workarounds are used. Of course, you can stand transducers up, but that's not always convenient for the end user. So what does that mean for the measurement? This zone has to be kept outside the working measuring range, and sometimes it's not an issue. But if the level gets into this zone, ultrasonic levels can behave a little bit unpredictably. They can hunt around for other echoes, and that will often include indication of a level lower than it truly is. And that can be obviously disastrous for flood or overfill protection. Workarounds like anti-submersion shields can help, but even then we can see them getting blocked up, or the level gets up inside them because of turbulence on the surface has scoured the level up inside the device, even though you have got an air pocket in there. Going back to the 80 gigahertz compact radar, it simply doesn't have a dead zone. From 30 years of development, better electronics and processing software, it's basically able to read right up to the device itself, and even when it's fully submerged, it will continue to stay in that overfill mode and operate predictably. The other one is focusing. False signals, you can't get away from them with any non-contact sensor. They all have to deal with them. These are unwanted reflections. No matter how much mapping and tracking that you do, they all can always get involved and interfere with the measurement. Like walls, ladders, pumps, pipes, weeds, branches coming in into view, and it can make the level signal jump up with a false reading, or jump back down again. There are many different ways of dealing with them, some better than others, but all can be fallible, even ours. Of course, the easiest way is to remove or minimize these unwanted reflections, and that's why focusing is key. If it doesn't see it, it can't get a false or unwanted reflection. So the tightly focused measurement path of the 80 gigahertz radar just focuses past all of that, past the walls, the ladders, the pumps, build up. And for example, one customer found that our radars gave much better, cleaner data without jumps, and they were able to do much faster and more accurate flood control and modeling without clearing up spurious data, which could sometimes take them a couple of days, just trying to work out which sensors in their network were actually giving them reliable information. So 80 gigahertz frequency sensors offer the best focusing, and you get reliable, smooth measurement without the jumps. And all the transducer sizes remain small too because of that. So resilience of measurement, standing up to the working environment. Radar level works in all winds and weathers. No stilling tubes, surface conditions don't matter, for example, and they can even measure 4 times a second to record wave height on the sea or average the level for tide gauging. When it comes to adverse environments, radar is unsurpassed for its operational resilience to build up or airborne interference. It's not sound-based, so there's no dampening of the sound. When it's in flight or on the speaker face, the dampening can still cause the signal to become unreliable. If you use an optical system like an infrared or laser system, the signal can't get optically diffused either. When you use one of these optical systems, again, you have to make sure the measuring path is clear and clean and purged, like we discussed earlier. And often you find that they start working okay, but then lenses become clouded or fogged over a period of time because deposits get left behind, even with purging and cleaning. Reliable radar sensors are continuing to work in adverse conditions, and they can result in big savings. For example, we've seen reducing or eliminating call-outs to sensors, just needing a clean or a reset for a lost echo can save hundreds of pounds in a matter of days or weeks. And of course, some gains are marginal. We're not going to say it's going to transform every measurement. A lot of them are working well as it is. But even with ultrasonic sensor outages, may only happen once or twice a year. If you can eliminate those or reduce those greatly and multiply that by tens or hundreds of sites, those savings could quickly add up, especially when you think of time and fuel needed for each time you visit, or perhaps worse, avoiding equipment damage or environmental incidents. So just in summary, I mean, why consider changing to a radar then? You get higher accuracy and better quality data. It also means that you get an operational resilience to process conditions like temperature and pressure as well as build-up. Setting up is now simpler than ever. Most are just point and measure, which results in lower reactive maintenance. And a wider measuring range up to the sensor means that more can be stored or you can operate with better safety margins. Radar has the widest application base from liquids to solids, even with the basic sensors, and that it reduces spares holdings. So as I talked about earlier, we've been coming to the market with new radars on and off for the last few years. So what's so different about this one? Hey, we got another one. Oh yeah, okay, tell me all about it. So here goes. Some of you may be familiar with this image from the past couple of years. We've already tested this 80 gigahertz technology format. Guess what? In the higher end markets where the budgets are bigger, and this really gave us a feel for the new technology and how well it worked. And that was being sold in tens of thousands of applications already in liquids and bulk solids. I think actually we've gone past 100,000 in 2 years. That's how quick the take up has been. And so today we introduce you to a new range of 80 gigahertz radar level devices designed for the water and environmental sectors with the same pedigree as the other 80 gigahertz devices that we've got in our range. And apologies, they're aimed at the water sector. Sorry about the missing image, not sure what's going on there. but basically that's water treatment and sewage treatment applications. Here's typical applications across all the industry, both liquids and solids, whether that's from open water during process, dry solid sludge cake applications, pumping and underground. So if we look at ultrasonic sensor versions, we typically have compact sensors, cable versions, and sensor with controllers that typically use a coax or specially designed cable and signal system between them in general. And so we had to look at how we can offer alternatives for all of those. So our new radars offer a compact version with a terminal housing for connecting a standard signal cable into. Then we've got them with fixed cable connections to IP68. Notice even the 30-meter range sensor on the far right still has only an 80mm diameter, yet only a 4-degree beam angle. An ultrasonic head to do that same thing would at least be twice that size, and it couldn't be loop powered because it would need a controller to provide the sound energy to go through the transducer. Talking of controllers, we've got new optional controllers capable of 1 or 2 inputs. They only need to be used with the sensors if required for a local display, data logging or signal outputs. They're highly capable, but all of the sensors I showed you in the previous 2 slides are smart and standalone transmitters, loop powered or with other options which we'll come to in a minute. Even the transmitters even have basic flow curves installed, so they can be a standalone small flow meter for an open channel flow application. So the controllers are not an essential part, but they obviously can provide you with the control you need locally. But if you don't need them, you can save time and money on mounting boxes in the field. If you don't need them, you can just connect straight back to your control system. So if we look at these ultrasonic sensor versions, for the first time, a compact, affordable and versatile radar can cover them all. What about the price? Well, that's the big question. And don't worry, we'll cover those later and provide them all for you. So just to cover what's inside our sensors, looking at the technology first, we have highly focused compact devices based on the 80 gigahertz technology. We're extremely proud of our own microwave radar chip inside, and it's specifically made for level measurement, not a proprietary part. It's designed and made by Vega. Hang on, sorry, I need to go back one. You can just about see, sorry, there's some lag on the transition, so I'm missing them. So you can see there, that's the size of the chip inside our radar. What about fitting them into your process? We've got fully watertight, fully welded for robustness and small dimensions, and cabling options minimize engineering costs. It's got 1.5 inches on the front and 1 inch rear threaded. Obviously on the unit you see there, it's designed to fit up against the ceiling, so that it's only got the front thread. And they're designed for optimal process compatibility and easy legacy sensor replacement. And they're ready for your applications. Completely potted internally to eliminate any risk of condensation or humidity buildup, and you can see from the X-ray and how it's looking inside. The different side or top cable entries just assist you with installation in confined spaces, whether that's a vertical confined space or a horizontal one. How safe are they? They've got LPR approval, because that's always one that we get asked about. Is it safe to use outside and with personnel? LPR stands for level probing radar, and they come with that approval as standard across the range. So you can use them wherever you like without any fear of interference. There are a couple of small places, somewhere around Jodrell Bank, maybe CERN, but we detail those. But if you've got any questions on where you're going to mount yours, and you know there's a space research station nearby, they'll probably come and find you. In terms of intrinsically safe, we offer an EXI zone 0, 1, 2. It needs an EX barrier or an EX rated controller at the back end, which you can also get as an option. But we also do an EXM, which is an encapsulated sensor suitable for zone 1 and 2. That doesn't need any of those barriers and can be used with a standard controller or be used with wiring back into the control system, as long as it meets the safety architecture. Sensor outputs, of course, there are different output requirements for different areas in the industry. You've got the water and water treatment works, where you've got distributed I/O and SCADA system at work on the plants. You've got sewer system and underground assets, pumping stations, where you might be using data loggers or need more local control. And then you also got remote sites for river and flood level monitoring, where often you're using telemetry and battery power, or you're scavenging power from another power source, so you've got some limitations. And we offer options for all of these: simple 420 milliamp loop power devices, HART, digital, Modbus, and SDI12, all optimized for low power consumption and fast startup, but also all, as I said, smart standalone devices in themselves as well. And sometimes you need to see it. So we offer graphic displays on the units with the housing, so you can actually see the setup that you're using. And we've also got a graphic display available on the controller, which can show you 1, 2, or 3 values. So you can obviously have sensor 1, sensor 2 input plus a differential, for example, if you're monitoring across a screen or a filter or something. There's also status colors. If all the animations were working, you'd see these nice color changes to the display, but sadly today you'll have to use your imagination. Imagine that screen changing different colors. You can select the color that you want it to change to if there's a fault or if there's any maintenance required to the system. And in terms of setup, there's not just the push buttons and remote displays, there's a smarter way. The color, the tip there was in the color. It's using Bluetooth, and we've got an option now for using secure, a double protected Bluetooth, which is fully encrypted. You use our app via iOS or Android phones. It's free to download, or for Windows products you can use Packware software, all backed up by pins, which if you run a My Vega account when you connect into Vega Tools or the app with devices, the pin numbers will be uploaded to your account and shared, so you can share them on the cloud with colleagues, for example, or just keep a track of them. But like all things, once you connect for the first time with a smartphone, it will remember you. Typical operating range for the Bluetooth depends a little bit on bandwidth you want as well, but it's around about 50 meters, 25 to 50 meters range, depending on, again, the amount of hardware around you as well. But we've never seen any major issues with that. So that's a great option when you really don't want to get close to the application, or perhaps somewhere you can't go. It means that I can program that device from where I'm stood taking the picture, rather than maybe having to climb down to it, or having to find a control cabinet and connect in with wires into a system. And places where if you could just reach over to get it, to check that the sensor's working all right, again, you can connect up the smartphone, even just see a basic echo curve to understand if it's reading the right rudimentary distance and the signal amplitude is what you'd expect it to be. Really simple to use, award-winning Bluetooth software. So whatever your requirement, our new radar offers a future solution. And they're proven already. We put models in around about 500 applications worldwide, from wet wells to pumping stations, open channel flow measurement, digesters, through the outside of chemical storage and dosing tanks. And we'll publish more of these details of many of these applications in the coming months as real user applications. Part of the trade-off for people to get an advanced device was give us some of the application data. So that will benefit people who are looking to use them, maybe looking for a reference. It means you're not the first person to actually try this thing out. So I hope that's proved us why we say, or we think, radar is the better ultrasonic. It's a bold claim, but we think the new 80 gigahertz compact radar technology is the start of a new era, particularly in non-contact level measurement for the water sector. We hope this has captured your interest in our new products and given you some insight into the technology difference.
So excited about
its development to help you
better, cleaner data,
reliability and control.
But
of course, there's also another really important
we
strongly value our customers. Relationship as a great level of precious supply. You may not have used us before, but we believe in partnership, support, and cooperation to deliver the best service we can. If you ever want to contact us for a free trial, not just of a sensor, but as Vega as this company and business partner, by all means, you can find out for yourself. Oh, about the prices. Knew there was something I had to cover. They're all available. So if you go to vega.com and search for any of our radar devices on there, you'll see that all the prices. We'll just give you a flavour. If you want to do more than 3, radar prices start with a price of less than £365. All the apps and the backup software is free. There are some nice extra features. But you can set up a device straight in the get-go.
By all means,
message me via email or LinkedIn. Like a live demo or test on free trial. Please follow Vega Controls UK on LinkedIn for the latest products and applications. And we'll also be sending those out on email to members as we move forward. Incidentally, we hope to about the live demo in the new year and new products when they're available. Because sadly, all the ones we trial and we're waiting for deliveries to start. And just so as you know, you can order them now direct from us. You'll be able to order them from our website and web shop in January, and all our products will be selling on January 2nd. Don't worry, we've got a stock ordering. The products we'll be back to talk about in the new year will also include a new battery-powered wireless cloud-based radar device. I can't tell you too much about that now, otherwise I'll get shot.
Thank you for your time today.
I hope it's been of interest. I'll now click back to the live camera for the sign-off, if I can. Back to the hand if they let me. I hope it's coming up, maybe.
Should be, Doug.
If you've got any questions now on the chat, if not,
I've switched back to the chat window, so if anyone wants any questions, please do enter them in the chat window. We'll hang around for 5-10 minutes or however long everyone wants to stay on. Thank you very much, Doug, for that. It was highly enjoyable, and I hope everyone else has enjoyed it. If you have any questions in the chat window, if not, and you want to disappear, then you're most welcome to do so. But remember that the next WIPAC webinar is going to be on the 22nd of January, where I will be covering flow-to-full treatment and the challenges of flow-to-full treatment in the next asset management period, as it's coming fast up on us all. I can see that Gemma's typing away, so I think Gemma might have a question as it's coming through.
Great.
If anyone else has a question, then please do use the chat window. So thank you to everyone for coming on this webinar. If there is any questions, then do stick around. If not, then please feel free to join us at the next webinar. So Gemma, you can see, I don't know if you can see that one, Doug, for use in wet wells, etc. Can you submerge the sensor in case of flooding? And how does this affect measurement?
So I'll cover that a little bit in the seminar. Basically, they're designed to measure right up to the sensor face, so you'll get a continuous measurement to the sensor face. We lose a little bit of accuracy. Please forgive us measuring at the time of flight over, sort of 20 millimeters. But we lose a little bit very close in, but we still monitor the level perfectly up to the sensor face and then when it's flooded, it will just stay in overflow mode. People have asked if we can measure past it. Unfortunately, not. It's not measured, but it will continue to perform reliably, keeping a level measurement out in the right place. So you don't need submersion tubes or anything like that. And the other thing you'll see, and if we get a chance to come back and we'll demonstrate it in future, even if some build-up gets left behind on the sensors, work very well. You've seen Oliver with the wet wipes and water sprays and Nutella that we put on the sensors to show them.
I certainly have, Doug, and I know there'll certainly be an opportunity at WEM, which is, of course, in under a year's time now. Okay, echoes through my mic are making Doug almost inaudible, so I will switch off my mic and let Doug.
Sorry. Ian, just say yes if you want me to go through that answer again. Okay, all right, that's fine. Yes, it's the good old sound around effect, I think. The feedback isn't brilliant, so thanks. Almost inaudible. It might have been the speaker at this end, I'm not sure, but of course we kind of got to hear what's going on. Mark, that's a really good question. MCerts, we are in the process of talking to WRC and also an MCerts inspection company who will be working with us to help us get the MCerts. Obviously, we don't see any major issues in it. We've already got one radar through MCerts of our current range, so it is something that's a priority. We'll begin that process in the new year, and we'll keep everyone updated. As far as the product's availability goes, as I said, it will be 2nd of January. I think some of the ATEX certifications may be a little bit delayed. It's the usual kind of rubber stamping of certificates. The devices are ATEX ready. It's just the paper trail. Delivery will typically be, oh yes, they'll be ready. I said, well, if they're ready in January, you can order one now and you would get it in the middle of January. Deliveries will be typically between 2 to 5 days, depending on quantities and stocks delivery. Of course, the other one is the B word, but I'm sure that won't affect deliveries. Anyone, any other questions? Power consumption, basically, the lowest power version we do is SDI 12, built specifically for the telemetry market. That we are looking at. We did a test with a large data logger manufacturer about a month ago with some people from an agency that looks after the environment, and we got a calculation from them that would last 5 years on one battery, taking a reading every 15 minutes and sending the data once a day. The power ranges, as far as I know, are going to be around about 9 volts up to 36 volts DC, standard 4 to 20 milliamp. The startup time is going to be 10 seconds or less to help eke out that battery power as much as you can. And the only other thing that may eat into that battery power, by the way, is if you connected it with Bluetooth, I think every day for God knows how long, that could also eat into it, because you're probably using a little bit more battery power using the Bluetooth in a sort of transmit and communication mode. If there, oh, so I've got another question coming in, I think. Excuse me, I'm going to have a drink. That would be interesting. Obviously, the cyber-proof battery unit for some sites that don't have power but require flow measurement, it's something that I've mentioned a couple of times to people involved in the sort of the MCerts certification about whether they would consider having an MCert on a compact transducer with flow curves inside of that just gave you a 4 to 20 milliamp or maybe an SDI 12 value or whatever in proportion to flow. Because at the moment, part of the MCerts requirement is that you have a controller and you have a device, and the controller gives you all of your relay outputs for samplers, etc., and does some sort of data logging. Yeah, it'd be interesting to know whether that MCerts product using AV has a back-end controller, or whether that's being treated as a compact device, as would, for example, a magflow meter. Yeah, exactly. It's when you, as soon as you put a controller in with some relays and outputs, they just use too much. They just pull too much power, because as soon as you start having to operate relay solenoids or have the provision to, the power consumption goes up from, you know, a few milliamps to tens of milliamps. And you can do it, but it needs a big solar panel and battery backup. It is technically possible, and we have done it in some applications, but to be honest, I think the costs are too high. So yeah, we would quite like the opportunity to look at getting an MCerts product for a standalone transducer, I think, or at least it then could input into a proprietary battery powered telemetry unit. As I talked to there, I mean, we can offer an SDI 12 device that's got flow curves and programmable flow curves inside it that could go straight into your data logger, and the data logger could be doing the logging and the transmission of the data. But at the moment, it's not allowed, if you like, for a level sensor doing open channel flow measurement using a control device. Any more for any other questions? Oliver,
I can.
I'll hand over to you.
So thank you very much for coming. If anyone's got no more questions, otherwise you can always contact myself or Doug, or post it on the LinkedIn page where I will put this recording. So thank you all for coming. Don't forget, next month, the 22nd of January on FFT, I'll be putting more details up on the LinkedIn group website and sending you all details if you'd like it. Thank you very much for coming today, and have a good Christmas. Take care. Bye.
Thank you. Bye.
Thank you. Goodbye.